Hello everyone. Today we are going to learn about web analytics and text analytics. So we are going to learn today what is web analytics and what is text analytics. So we are going to discuss about web analytics, or it is also known as the web scraping. It is also known as the web scraping. Web scraping. So this means from a website there are lot of data, lot of informations. How can we bring all of those information at once in Python? At once in Python, how can we bring those things? Okay. For example, if I want to discuss these things more deeply, let me take you to that page. In this page, there is a web scraping, that one. So let me copy these things and show you in the Python. Maybe if I go there, or maybe if I open it, let me see if I can open a tab. Let me open a tab in here. For example, in this tab, I just want to type these things, Control V, and then take a look at that, what I got. So this is the website. In this website, this is known as the Avalon project, which preserve all inauguration speeches of our presidents, that is American presidents. That starts from George Washington up until now, all the president's speech. So he has two speeches. If I click in there, George Washington 1789 and 1793. This is his 1789 speech on April 30. This is his second term speech on March 4, 1794. This is the two speeches. So my purpose is to bring all of these speeches at once in a data frame format or in a text format in Python. That is known as the web analytics. Down the road, if you work as a business analyst or data analyst or data scientist to a company who sells online product, who sells product online like Amazon or Walmart or Costco or maybe Target, they sell product. They sell product online, and then after buying the product, people make a comments of the product and their service, all of these things. Even like in the hotel businesses or maybe Airbnb businesses, people rent the Airbnb and then they write a review about the living conditions of that hotel or of that home, right? So lot of text data nowadays are generated. How can you bring all text data at once in your programming language, Python or R or SAS or some other? How can you bring all of those things to your computer? That is known as the web scraping or web analytics. So first task is to bring all the data to the Python or some other software. Okay, so now in this lecture, first part of the lecture, we are going to learn web analytics. So that means we will bring all of these data at once to Python. Okay, so as I give you, after bringing that data, then what we are going to do, this is the first part of the lecture. The second part of the lecture is text analytics. Second part of the lecture is text mining, text mining, or NLP, natural language processor. These are the two topics I'm going to discuss. In NLP, I'm going to discuss what is stopwords, what is what is like special characteristics like the ampersand and then dollar sign and then star and then all of these, how can we get rid of those things, and then how to construct the word frequency, which word is coming more frequently, and then we want to construct a word cloud, which is a visual representations of the words. By their size we will determine that if one letter font size is bigger compared to the other, so that letter is appearing most of the time in the text. And then we will do sentiment analysis, and we will also do plot, something like that. So in text mining we are going to learn these things. Okay, let me start with the Python code. So this Python code, we are starting web scraping. This web scraping, if you take a look at that web scraping, so these are the packages which we have to use in order to do the web scraping. I run this data and then I run this URL. This URL, if you copy and paste in your browser, then you will get the website that I just discussed. That is called the Avalon project. Avalon project hold all the inaugural speeches of US previous and past present US presidents and their inaugural speeches. When they take that, then we have to do this URL. We have to write request.get. That means I am getting the URL. So that means in this case, request.get, these are the keywords. We do not have a control on that. The people who develop Python and packages, they use this keyword in order to bring websites data at once in the Python and R for further analysis. So request.get URL, we are getting this. After that, we are using a package, beautiful soup, that we mentioned in here, beautiful soup, that will be used on the response, and then after response, then we have used the content in here. For example, if you write here response, you are not getting in here. You are not getting anything in here. But if you write in here, let me see whether we get some output from there. So when we write response.content, everything that are on that website, everything comes up. Everything, all of those things showed up in here. And all of those things showed up in here, this content. Now, in this content, like these are all coming from the website. Okay. So that means they are bringing what is in the content. And then after writing this on this content, if I do the HTML parser means parser means in the sentences they are they are considering the sentences which are in different pieces, pieces. They are doing HTML parser. So all website is usually written by the HTML. So if I run this and then if I write here soup, so now in this soup part, if I write, we got all the things that was mentioned in the website is showed up in here. Everything that we mentioned in here. So when I write the response contents, it did not bring all the materials that I mentioned. Now you can ask me question, where did you get all of these things? You can ask me question, Professor, I do not understand when you write response.content and the material showed up. Where these materials is coming from? Response did. Okay, where these materials is coming from? So you said that I do not get it. Where did these things come up? Please, could you explain me? And then again, you said me, previously you just run response.content and you got these things. Now you again run response.content and you are doing on this response content or HTML parser, then you get again a lot of these things. Where did these things come from? If this is your questions, now I'm going to show you where these things come from. Let me take you to the Avalon project. So this is the Avalon project. The response.content and response.content and HTML parser, when we apply, on the website which we obtained by the get request. After running the get request on the URL, so the information is coming from here. This is the website, and if you right click on the website, and then if you click on the view page source, and in this view page source you see all of these informations. Okay, all of the information. So now let me take you to the Python. This Python, you are seeing all of this. For example, Franklin D. Roosevelt, right? Franklin D. Roosevelt. This is the things is showing in here. Take a look. TR starts in here and TR finishes in here. So this is the end of this TR comment. So that means this thing. So take a look. Roosevelt, Franklin D. Roosevelt, Franklin D. Roosevelt, right? Franklin D. Roosevelt. If you try, you will find Franklin D. Roosevelt. Where is Kennedy? See, Franklin D. Roosevelt, and he was a US president for about, I think, 14 years because of the Second World War, 1933, 1937, 1941, and then 1945. He is done for this longest run president, Franklin D. Roosevelt, and after that other. So this is what we have seen. Again, let me explain what does this mean. So this means that this is the Avalon project. In this Avalon project, if you do the right click and view page sources, and then you will see all of these things. So in our Python now, after bringing this is the URL, which is the web page address, and I get request.get web page is obtained, which is response, and then response.count, I pass the HTML. So now everything is showed up in my Python. Now, in the Python, I do not need all of these informations. From this soup that I have everything from that web page, or from that web page, they have everything that in that web page. But I am not interested to bring everything from that web page. I want to bring certain things, only their speeches. That means I want to bring only this. I want to bring only this. I want to bring only this. This is the presidents and their speeches. I want to bring only this. This is the president and their speeches. Okay. So now, how can I bring that? So soup is this one. In this soup, here is everything. I want to find only tables. See, in the soup means, this soup means is that one. That one means all informations from the web page which already brought, but we are not interested all informations in the web page. We are only interested on certain tables. Now let me take you to the tables. So this is the things. Are you seeing? Okay. Link. Here is the one table that is begins in here, and the table ends in here. So this is the ending of the table. That is the beginning of the table. That is the beginning of the table. That is the ending of the table. When you see forward slash, that is called the end of the table. This is the table, first table. Now come to the second table. Are you seeing second table? It starts in here and then ends in here. This is the second table. Okay, second table. So this is second table, and that is first table. These two table is gone. We are interested only in the table values. Now come take a look at the, there are no other table informations up until here. This is the third table. So this is the third table that starts in here. So first table starts in here and it ends in there. Second table starts in line number 32, ends in line number 46. Let me again telling you, because this is very important to understand. When you will do your homework, you need to understand these things. First table starts with the line number 12. First table ends with the line number 23. beginning and ending of the table in here. Second table starts with the line number 32. Second table ends with the line number 46. When there is a forward slash before the table, that means that is the end of the table. And then after that, if you check, you are not finding any table up until line number 55, you will get a table. Line number 55, you will get a table, and then you will find the end of the table on the, you will find the end of the table on the, you will find the end of the table on line number 232. Line number 232. So that is the third table. Okay. That is the third table. So third table contain all the speeches of all American presidents, third table. So we should focus on the third table. So now soup has all information. Line number 15, soup has all informations about the web pages. Everything has been brought to the Python already. Now I want to specifically focus only on the table. There are 3 tables. I want to focus only on that part. Okay, that part. Now, after finding the TBLS tables, that means 3 table, I only focus on the third table. So third table focus, that is why I write here PD panda dot read HTML. I want to read HTML structure str tables, that I have created in here. This is the tables where all 3 tables information is there. From that 3 table, I want to pick only third table. So here 0 means 1 table. Python considers 0 as a row. Okay, so 0 means 1 table, 1 means 2 table, 2 means 3 table. So I put here 2. That 2 means I am focusing only on the third table, because on the third table, all presidents, all US presidents inaugural speech are in there. Okay, so that means these things, and after that I put there 0. So that means each row from data will come from each table by the row. So that is why they put here 0. 0 means by the row, first row, something like this. Okay, now let me do tables. This is the third table information is in here. Now if you write here speech underscore list, you will see speech underscore list. If you write, you will get these things. So presidents and their speech list, I put that by the third table. Only these things is coming in here. Structure. Now this speech list has been created for the different presidents on their first and second and third and fourth term. Only one president served up until fourth term. So this has been brought in there. Okay. Now I want to prepare I want to write the code so the data could be brought. So take a look at that. Prepare the links by replacing these with the base URL. So what it is, a function I am defining with a link as their argument, and return link dot replace. These things should be replaced by that. This the double quotation mark missing is replaced by that. Okay. So these things, what I'm doing in here, I'm writing a function prepare link, and then if there is a pattern double dot, then that pattern should be replaced by this avalon dot this. Okay, so this is the first part of the some part of the previous link that I ran in the line number 11, in the line number 11. So what this, if we see a double dot, then we replace this. Let me explain the double dot. Are you seeing double dot in here? If I get a pattern double dot like that, it should be replaced like the base. So all the speeches starts with the double dot. So that is why I am saying if there is a pattern of double dot, and then replace this by this one, usual one. Now what I am doing, this pattern is obtained. Now I am extracting the links from the third table on the pages. How? Prepared underscore links. A is a column of the each table that are mentioned in there. Take a look at that. Are you finding in here A? This is the A. And A, I take href of A. I take href of A for each speech. So A href of A, and that quantity is being used as an argument for the link that I have created in here. Prepare links I have created. So now it is a function of link as I am running these things. So what they are doing this replace criteria in here, because prepare underscore link is a functions that I have created. Now I put their argument like this. And if this is the argument, what they will do, they will replace this quantity by that. So A and href in prepare doc links, I put it in there. Then what would be the output? Output would be link replace this by that. So now come in here, A reference. So if I find in this case, like any pattern like this, it should be replaced by that. For A in the tables 2. Tables 2 means third table. 2 means third table. For A in the tables 2, in all the um all the tables in all the president's speech in table 3 has a. For A in the tables 2 dot slick stretch A. So stretch A is what? This is the stretch A. So stretch, you start with the stretch, come here. You start with the stretch and finish the stretch. And within stretch, I have considered here A. So that is why we have written here stretch A. So let me run this. After running this, now after running this, extract the names of the speeches from the third table on the page. From the third table on the page, now I extract the speech. How can I extract the speech? A dot get text. Get text is a keyword for A in the tables 2. That means table 3 dot select trash A. So we are selecting trash A. In that way, extract the name of the speeches has been selected. Okay, after selecting this, now we are going to write a function get speech by using previously created functions and the code. Now those of the code and function are going to use in the format of a function in order to bring all the data. So our new function name is get speech, and link is the argument in here. And I'm trying make a get request to the speech URL and parse the response using beautiful soup. So response request dot get link, request dot get link. So link is a argument. So request dot get link, dot get link I put there. Now on the link that I have created response, I am putting beautiful soup response dot content HTML, HTML and parser. After doing this, in this case, I got everything from the link. So now speech, I am finding if there is a pattern like this, double quotation dot join p dot get text for p in the soup select p. Now you have to understand what does this p means. Here p means it is a for loop. You remember I goes 1, I takes value 1, I takes value 2, I takes value 3. So that is why p dot get text. So that means each time p-value is running, so you get text for what? For p in the soup select soup. That means the soup is beautiful soup, and then response content from there soup dot select p, and then you slow down these things little bit, time dot sleep, because sometimes if you want to import all the data from a website at once, and because of their internal program written there, they might think that, well, I'm a person who is uh, downloading all of their informations for some bad intention, so they might stop us to download the data. In such a cases, if you put time dot sleep, then they will download, maybe they will import maybe first three data and take a 1 second break, and then another seven data, and they then take another 2 seconds break, 3 seconds break. So this is what they have done, so that downloading can be done perfectly without overloading of informations, or maybe without having heavy jam in the website. Okay, so then we got the return speech. Return speech is this one. So what is the beauty of these things? I have used in here beautiful so get text that we created in here to get the speech in this format. Now what else we say? Accept request dot exceptions dot request exception as E. If there is an error, return none. So what does this mean? This means, suppose one of the US president, his speech is not available in there. So I have seen that if you go there, one of the US president's speech is in there. Okay, if you go there, so in such a cases, if speech is not in there, then what should we do? Ignore that thing. So data has been brought by using this. Okay. Now what we want to do? We want to do retrieve the text of each speech. Get underscore speech. Get underscore speech. Get underscore speech is a function I have written in here, and then link for link in the links. Okay. So for link in the links, if these things is run in this format, it will take little time. I have to explain this line number 53 to you so that you should not be uh, mm, you should not be worried about how this line 53 works. Okay, so let me explain these things to you. See this link, right? Instead of link, you can put here I, you can put here I, but that links you cannot change, because the values of the link, first link and second link, are in the links that we have created in line number 28. Okay, links has been created line number 28. This link, this is just the argument. If you put here C, then you have to put all the link inside in there as a C. This is just the argument. So if you have a question down the road, I do not understand this link for link in links. The last links I already created on the line number 28. All the values of this link and that link are in here. Okay. So now everything is done very clearly. So let us run these things. So this is our data sets. Now if I write df dot head, and you will see the data. So df dot head, first one is 1789, and this is the fellow citizens of the Senate of the, like this way it continue. Okay, this way it continue. The second one, fellow citizens, and so that means data is coming by year, that means by name, and then there are all the is showing up that way. All the president speech are showing under the text. Okay, so we can create another column of the like presidents. Where is this one, right? Names. Yeah, names. Just check here names. Names has been created like that way. Let me check the speech list. If I write here speech list, take a look at that, how the speech list has been created like that way. And then all of those presidents and their first term, second term, third term has been put. So our data here, each presidents and they are serving terms in this one, in the speech list. And then finally, that one is just the one president. Head. So this is his first one. This is his second one. That is the second president. That is the third president. That's the way it will go. Okay, so you have learned how to import the data in Python. Down the road in your homework, what I say to you, this is your homework problem. Web analytics or web scraping part. First, import all faculty informations from only one of the following website. So there are many website has been given in there. So each of you will bring the informations from this. Like the way on the line number 11, I put the informations in there. Okay, you will put the informations in there, and then you will follow the procedure the way I have. So one of these website you are gonna use, for example, if a student use like the http physics.georgiatech.edu people, for this one, if one student use this one, that means he has to bring what description mention in research. So let me check in there. I hope it is still working very fine. Go there, come here, right here. Yeah, so School of Physics, right? So all of these professors are in there. Okay, now what you will have to do, you have to bring what, come in here, you have bring description mentioned in the research, description mentioned in the research. So he is the professor, you click on there, and this is the research. Okay, so you have to bring all of these things, only research part, all of these things. Not only one professor, all physics professor, all physics professor. Okay, so see, I just want to tell you, I have shown you how to bring, I have shown you how to bring all inaugural speeches of United States presidents in the Python. I have given you a code. I have shown you the code. I have give complete explanations of the code. You now understand by watching my video what line of code means what. So you will do this. Right click on that and view page source. View page source, you will see. Similarly, HTML like this, import like this, you'll have to find like that way, and then check how can you bring all physics faculty from there to R or Python, okay? So the way I have shown you, you have to do exactly same way, but your approach could be little different than mine because I don't see any table in here. Control F, TABL table. Okay, let me see academic tables. Okay, so you have to use another format because tables are not in there. So so you understand like the homeworks problem, one of the website you will choose. After that website, each person from that website, you have to bring the information. What informations that I mentioned in the parentheses. For the physics faculty, you have to bring research. For the economics faculty, you have to bring the overview. Okay. For the civil engineering, CE, you have to bring biography, CE. Okay. So I hope you understand this question problem. Now let me take you for doing the text analytics. Okay. Text analytics will start from there. So this is the Barack Obama got elected as a US president. How can we do text analysis of his inauguration? So this is the way declare your path, like where your data is saved, line number 7. And line number 7 is to find your working directory, and line number 9 will help you to set up your working directory. After setting up your working directory, I run the line number 11, which is the Barack Obama's inaugural speech. So where did I get Barack Obama's inaugural speech? I got it somewhere and I saved that Barack Obama's speech in text file and then I read it. Okay. So down the road, if you will become an NLP scientist, NLP data scientist, natural language processing data scientist down the road, if you will do, most of the time you have to import the data from the web page, from the website. Only few cases you might need to run text data, because in order to run the text data, first of all, you have to get the text. That text should be downloaded or should come in a text format by third party. Okay. But if you are a like the fundamental NLP researcher, fundamental natural language processing researcher, you have to download all of your data from the website. And I have shown you in my first video, today's first lecture, how to import data from the website, how to import text data from the website by writing maybe 50 lines of code that I have shown to you. Okay. I hope you understand. Now, this is my data. After reading the data, I need to read the data. After opening it, I need to read it. So line 1 is the Obama's data corresponding to line number 12. If I write a line 1, so this is the Obama's speech. Okay. Obama's speech, I think 2 speeches they are together. Okay. All of this is Barack Obama's inaugural speech. Okay. After doing that, I need to do the tokenization. Tokenizations what? Now take a look at this. In these speeches, there are some, these things is showing up. Okay. So I want to make them beautiful speeches by taking out some of those things. Tokenization is the process of breaking up a given text into units called the tokens. We will break it up into tokens, maybe words or maybe sentences, something like that. Tokens can be individual words, phrases, or even whole sentences. So you understand what is that. So tokenization is nothing but the entire text could be broken into words or a number of words or a whole sentence. That is the tokenizations. Okay, so it should be beautiful format. Currently the line 1 showed me data in this format, but when I run the tokenizations, take a look how it will be different from the line 1. So this is the line, this is the line 2. So that means each sentence become a token. Take a look at that. My fellow citizens, and I stand here today humbled by the task before us, grateful for the trust you have bestowed, mindful of the sacrifices borne by our ancestor. So this is a one token, that means one sentences, and then there is a comma, and then new sentence begin. I thank President Bush for his service to our nation, as well as generosity and cooperation he has shown throughout these transitions. This is the second sentence. Now, previously in line 1, when I output, I did not get that beautiful sentence within the quotation marks. Okay. My fellow citizen is not ended up with the quotation mark. I thank President Bush. This not ended up with the quotation mark. So they tokenization means beautiful, beautiful presentations of the speech that that beautiful presentations should be either in each word separated by the other words, or it could be a sentence that is separated by the other sentence within a quotation mark. So you understand what is tokenizations. Now I want to put this in a beautiful data frame format. So now take a look at that line 3 dot head. It will be a data frame format. Take a look at that. Now my each sentence has become a each sentence now become a row. Each sentence now becomes a row. Each sentence now becomes a row. Data frame format, which is line 3. Okay. And then I have shown you head. And then here 0 is written. This 0 should have now named a text. I want to put it a name as a text. So I now put it in here in this format. Line 3 dot columns equal to text. Now, if you take a look at this one, I want to name it as a DF data frame. Now take a look. Now text appear. Previously it was just a 0. Previously it was just a 0. Okay. So data frame format. Now in this data frame, all the uppercase letter should be lowercase letter. How can I do that? df.text as type string dot string lower. So these are the cases. All word is now in the lowercase. Okay. Now I want to express each sentence to a number of words. Okay. Now see, are you seeing there 0? So Python starts from 0 instead of 1. So this is a 0 row. That means first row in other software. So now entire sentence should be broken into a number of words. So let me run these packages, and then regular expressions. I just put the regular expressions as a shortcut name. These as now shortcut name like that way. Then they want to apply this function where, are you seeing within quotation mark, and then there is a backward slash word w plus, that means word. So that means we want to do it in the format of a word. So now let me apply these things. Regular expressions on tokenize, regular expression tokenize, apply in there. I want to apply this part on what? df.text. df.text, I am taking df.text and then apply regular expressions on there. on tokenize, and then take a look. New column will be text.token, and then take a look at the head. Now take a look at the head. Previously it was text, now text token that I have created in here, text token. And then my is a one word, fellow is a one word, citizen is a one word, I is a one word, and rest of the things, these things has been kicked out. These things has been kicked out in here. Okay, so now stop words. What is stop words? So in the English sentence, most of the times um, there are letters that come with the preposition. There are words that are prepositions, conjunction, interjections. For example, in, if, and then or, on, to, from, all of these things. So those are the words we should not consider in NLP, because those are the preposition, right? We only need to find the words that are neutral word, not a word that is not. We do not want. We want only three types of word: neutral word, good word, bad word. Okay, neutral word, good word, bad word. Okay, so these are the three types of words we need in order to do the text analysis. So in this case, now if I run this one, import natural language toolkit, NLTK. NLTK means natural language toolkit. NLTK means natural language toolkit. So I imported that, and then I also download the stop words. And now if you do NLTK corpus.import some packages, if import, now if you write nltk.corpus.stopwords.was English dictionary, if you want to run this, this is called the English language stop words. And then if you type here stop words, you will see these are the all stop words. Okay, did not, could not, are, have, d, o, so I would. So these are all the stop words. How many stop words are in there? If you bring it in here, put here le and len, and then if you type in here 179 stop words. So in the Obama's speech that we ran, and then we tokenize is in the sentences, and then we further process the tokenized sentences to the word. Now from that words we want to get rid of any stop words. So from the tokenized from the uh, from the tokenizations of the words, we want to get rid of any stop words. Okay, after regular expression. Okay, after regular, so let me tell you. So Obama's text, and then Obama's tokenized sentences, and then Obama's regular expressions word. These three things I have created. These three things. If you want to take a look at that, take a look at that. It is it has a df dot columns. df.columns has text, which is the original Obama's text. Okay, and then text token, and then there is a oh, I did not write that one. Text token. Okay, I'm going to write it later then. Okay, so now these stop words, you have seen what is stop words. Now suppose among these 179 stop words, there is not a 2-3 words that is coming from another languages. Suppose the American president is from Spanish origin. His parents came to USA, and then he was born in here, and he became US president. Now he learned some Spanish word from early childhood. Maybe during his speech, accidentally he said one or two Spanish word. Those words are not in the stop word list. Okay, those words are not in the stop words list of those 179 words. How can you get rid those specific words? So those are customized words. I can make a program, I can change it, I can create a list of stop words, so those could be removed as well. For example, my stopwords, I want to put HTTPS, okay? And then stopwords I have created in here, and then I extend that by my stopwords. So here I put some other words, suppose blah, blah. And then I put here um, uh, C cube, C cube, something like that, or some other word. So I can write it in here, and then when I append it with my existing stop words by extending my words, then it is extended. Okay. So now my stop words has these three as well. Now stop word I want to remove. So text book, I am from the df text token. I take the text token, and on that I apply lambda x item for item in x. This x is that x. That x is the function of this one, this x. Okay. So you can ask me what is x in here. X is in here is the X argument is used here as an input from text token. So because from the DF data, I take that information text token, and after taking this text token, I am applying on the text token X. Item for item in X, if item not in the stop word. So if item is not in the stop word, then I want to keep that item. Take a look at this, run. Now take a run these things. We have this text and text token. So this is the original text, and now that is the text token that we take out all of those stop words. For example, take a look that so is taken out. So is taken out from there, and is taken out. Is not in here. Is not in here. What else? To is taken out. See, to is not in there. To our nation. Fellow citizen, stand today. Here is taken out. Here is taken out. Today, Humboldt is fine. I taken out. Thank, president is fine. Bush is fine. For is gone. For his gone service. So that means these are stop word. Now I am cleaning the stop words. Okay. After that, now I want to remove infrequently used word. Okay, infrequently used. So remove infrequent words. We first change the format of the text token to string and keep only words which are longer than 2 letters. So if there is any letter that if there is any word that has 2 letters, we want to get rid of that. So what we are doing in here, import panda, and then the line number 57 is telling that in the data when I will display, I want to display a maximum of 5 columns in the data. So that is what the pd.set underscore option display dot maximum columns. Okay. Now I'm creating text string from the text token. Text token is the new text data from where all stop words was removed. Now in the text token, I want to have words that is bigger than 2 letters. So here, take a look at that. I took the text from the DF data. I took the text token variable. And then I am applying on that lambda x. What is x? X is an argument on that. And then I am joining for item in X. This X, if length of that item is greater than 2. Length of item means each word they pick, if that word has a length greater than 2, that means the word must be of 3 or more letter words, then keep that. That is the meaning of this. And then finally, if I run this, take a look at that. I am running text token, text string, text token, text string. So this is the original text. This is the text token after removing stopwords, and that is the text string after this. And then I am writing it in the format of a I'm writing it in the format of a string so that there is comma and other things is gone out. Okay. Now create a list of all words. So what I want to do, I want to join all of these words together. Then I got this one. Join word for word in df text string. So df is the data, text string is this variable. Now I want to join all of this, and this is what I got. Now if you take a look at the all underscore words, then this is what you will get, all the words. Okay, all words you just got. Okay, so now after getting tokenize all words, I want to do tokenization of all words. So now take a look at the tokenized underscore words. So tokenized means there is a quotation mark and each word is now separated. Okay. Now I want to find the frequency distribution, which word is coming more frequently. This is the package we need to run. Then this is what is for the frequency distribution, and line 71 is showing you frequency distributions. So applause is coming 25 times. Must is coming 24 times. Nation is coming 18 times. America is coming 18 times. People is coming 18 times. The new is coming 17 times. Time is coming 16 times. Every is coming 15 times. Today is coming 13 times. And is coming 12 times. In what? In the Barack Obama's speech, after reading the speech in the format of a speech and then transforming that speech by cleaning stopwords, by tokenizations, and then by further tokenizations for the each word. And we find the frequency of the top 10 words, and we find that applause is appearing 25 times. Okay. Applause is appearing 25 times. Now I want to drop a word that is appearing less time, less frequency. If any word is coming in the entire speech only one time, I want to delete that word. How can I do that? See, df, I am taking text token, apply lambda x dot join item for item in x. If f distribution item, f distributions that I created in there in the item is greater equal to 1. So that means any word that is more than 1 times appearing will be kept. Other will not be kept. So this is what we are getting now. Okay. Let me see if we can find one. Okay, so we have to see more. So for the first 4 sentences, half of it, first sentences, second, third, fourth, fifth sentences, we do not see any differences. So that means in other sentences, other part of the sentences, if we take a look, we will definitely find that some of the word are removed if it is appearing only one time. Okay. Now, this is the, we want to compute now some kind of graph. These are the packages. And then, okay, what is lemmatization? Okay, lemma. So let me write it. What is lemma? So fundamental word is discover, suppose. Discover. Okay. But it has how many? Discovery. Discovery. And discovered. Discovered. Okay. Discovery, discovered, something like that. But the fundamental word is discovered. So this is the root word. This is the root word. This is the root word. Okay. Discover is the root word. And this is the like the extension of those. Discovered, discovery, and then maybe some other format. Okay. So if there are in the speech discovery, discovered, discover, all of these things coming, that means what they are doing, they are lemma. Lemma means small mathematical rule or small mathematical formula, small mathematical theory is called the lemma. So lemma, by using lemma, by lemmatizing, they reduce all of these all of these uh, similar words to only one word. So that means this word, this word, this word will become a root word, discover. That is what called the lemmatizing. Okay, that is what called the lemmatizing. So wordnet.lam, wordnet lemmatizer, I run this one, and then text string lemma. So that means I am using, I am creating a new column from text string to a new column, text string underscore text underscore string underscore lemma by by creating root word for the words that has the same root. Okay. So now I want to do these things. It has been lemmatized now. After lemmatizing, we can check whether lemmatized and non-lemmatized has the same length. How can I do that? This is F distributions. This is a DF F, and this is a DF of the lemmatizing one. And I want to check whether is this equal. And then if you find DF dot head, you will get true, true, true. So if we take a look at lot of rows in here, then you will see they are not same. For example, let me show you quickly by running another line of code. For doing that, I need to change the set option display. I want to change the set option display. I have to change it in here, set option display. Come in here. Yep. So this is what we want to check. This is what we want to check whether there is a true or there is an unequal one. Maximum display maximum rows. Change it to rows. Rows equal to, suppose I want to put here 20. So let me run it. Good. So then let me run it like this. And then let me run it DF and then check. So they're all. So even though I'm asking to show them 20, display maximum rows. Okay, display maximum rows. Check. Okay, display maximum rows. Just give me a second, okay? So many things now we have to memorize. I have to quickly check the code. Yeah, that is what I saw. Why it is not showed up then? I want to see. Let me see if I can do these things. Maximum rows. Okay, now let me see. DF. Okay, now I see. Okay. Are you saying true, 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 true? I want to find only one false. Please come. I want to find only one false. It's not coming. So that means in his entire speech, there is no, in entire speech, there is no lemmatization of the word. There is no, like all the root words are used. All root words are used in Obama's speech. Okay, all root words was used in Obama's speech, so we cannot see this. So let me run that one. This is what we done. Now show the level of counts. It has been shown. So this is a package. Okay. If this package, suppose, let me tell you, if suppose this package is not working for you, then what you will do, you will just copy these things. Either, first of all, you try to run these things from your Anaconda Spider from here to there. Suppose it is not running from there, then what you will do, you just copy these things, and put here command. Oh my goodness, I don't know what happened. If it is not run from there, what you will do, you just go there, and there is a Anaconda notebook. You could click in here and then paste it in there and hit enter. Click in there, launch, paste it, and then hit enter. If you did not. So now we have few more minutes to see what cloud and what frequency, and then sentiment analysis. Then we are done. Other option is to run it from here, command line. Command. And then if you write here, Okay, let this package be installed first, then we will do the rest of the thing. Take little time. Okay, it is done. It is done. Now I want to from the lemmatizing string, I want to join all of those. So lemmatizing is done. If there is a word which has a noun, but it has a format of adjective, it has a format of like adverb, it has a format of verb. In such a cases, lemmatize pick only one by cutting the uh, by cutting it down to the root word, by cutting it down to the root word. So after lemmatizing word, we want to join them. We created these things. Now we are going to create a word cloud. This is the word cloud we have shown. This is the word cloud. If you take a look at the plot, this is the word cloud. So in this word cloud, we see that maybe applause or must has the biggest font. So must could be the or maybe applause or America uh, would be the word that is appearing most of the time. Now, if I want to take it as a beautiful different format, I can also see that in a pie format. Here is the format. So in this case, maybe applause and nation and must, they are appearing maybe same time, or maybe must is appearing highest number of times. Okay. Now frequency distributions, if I want to take a look at the frequency distributions, that is the frequency distributions, and most frequently used three words is applause is up coming 25 times, Mars is coming 24 times, and nation is coming 18 times. Okay. So from the figure that you have seen previously, plots, so applause is coming 28 times, and must is coming 24 times, right? 25 and 24 times. And nation is coming 18 times. Nation is coming in. So applause, must, and nation. Okay. So that is the way we got. If you want to see the tabular format, this is the tabular format, which is much easier to visualize. So I want to plot the common words, top 10 common words I want to plot. Here is the top 10 words. So applause is coming that many times, and generation is coming maybe 11 times, something like this. Applause is coming 25 times, something like this. Okay. We can also plot, updating the plot. Using same plots, no updates takes place in there. Now I want to do the sentiment analysis. That means how many words are positive, good word, and how many words are threatening, discouraging, hateful, divisive, and how many words are neutral. Those are the things we are going to see in the format of a graph, as well as in the format of a tabular presentation. But let me run completely. So we see that negative word is appearing in her entire speech. Negative word is appearing maybe 38 times. Neutral word is appearing maybe 50 times, or maybe 45 times. Positive word is appearing almost 140 times, something like this. Well, I'm going to stop in here. So in your homework project, what are you going to do? Let me tell you. After running one, importing the informations from this website, one of this website, once you finished importing this website to your computer, then what you will have to do, you have a data frame format data, then you use the text mining data to get rid of stop words, punctuations, number, apostrophe, any other unexpected words, and name the new data as D2. Show the most frequently used 10 words in the D2 data. Show the bar chart of the most 10 frequently used words in the D2 data. Show the word correlation of the D2 data. This is what I gave you new word cloud and sentimental analysis. Okay. So very easy, straightforward homework. So I'm going to stop in here. We have one more lectures, which is on the neural network. Thank you very much. Bye.